What happens when sustainability meets high performance? Find out what Flatiron Institute and Lenovo did to earn the #1 spot on the latest Green 500 list. Learn more at news.lenovo.com. That's news.lenovo.com.
As we decarbonize the electricity grid, which is happening pretty quickly over the next few years, the Scope 3 supply chain is turning into the biggest proportion. If we can move electrons around, which is computing, to make it more efficient to move the atoms around, that's where the energy really is, then you're providing optimization for these physical processes where the real carbon is being emitted around the world. These are very big individual machines, but it's not like there are thousands of frontier-sized systems. It's just one. So the total aggregate capacity of HPC is relatively small compared to the total aggregate capacity of enterprise computing or cloud.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey, Shaheen, it's great to be with you again.
Excellent to be here as usual, Doug.
Yeah, we have a great topic for our podcast episode today. Our special guest is Adrian Cockcroft of Orion X, and of course, that means he's a colleague of yours, Shaheen.
Yes.
Adrian has a lot of experience in the area around carbon, environmental, and ESG, environmental, social, and governance issues related to HPC and carbon emissions. So, Adrian, thanks so much for joining us today. And please tell us a little bit about your recent experience as it pertains to this topic.
Yeah, thanks for having me on again. So I was on a little while ago. Happy to be here. So what I've been working on in the last few years is sort of the intersection between the computing industry and what's happening in sustainability. And in particular, the sort of measurement and optimization of what we're doing in the IT industry in general, but enterprise computing, cloud, and also looking now at HPC and trying to figure out what's going on there. How does that relate to what's happening in the world in terms of renewable energy and all of the other sort of things you have to do to measure and report on that, and then what's happening general sort of over the next few years. So that's my interest. And then, as was mentioned, I've been working with Orion X for the last 6-9 months, something like that. But before that, I was with Amazon. I was a VP at AWS for a long time, and then focused for the last year or so on sustainability and a couple of different projects. One was managing the Sustainability Data Initiative, which is, think of that as sort of a petabyte of interesting sustainability data that's available for free in the cloud. And then the other part was figuring out what's all the messaging and everything we needed to do to get the AWS field technical and salespeople on board with, like, this is how to think about sustainability. This is how to work with your customers on it. So I spent quite a lot of time getting all of that stuff straightened out. And that's been the focus since I left. I've been particularly talking to people about how do we optimize the sort of enterprise and compute usage of IT, and how do we make that more sustainable going forward.
That's great. And, in preparing for this episode, we were chatting, and I was really impressed that you paint a pretty optimistic and positive picture, at least about the IT industry and energy consumption and the strategies that the industry and companies within it have adopted.
Yeah, there's actually a pretty good story here, because the IT industry in general and the large technology companies have been amongst the first companies and amongst the leading industry in terms of decarbonizing. We've seen very large investments in renewable energy, in particular from all the different hyperscalers. The largest purchaser of green energy in the world and renewable energy in the world is actually Amazon right now, with over 20 gigawatts, and Google and Microsoft are in the somewhere around 10 gigawatt range. And other large companies, again, they're investing in building wind farms, solar farms, battery farms that around the world to supply green energy for their operations. And what that's done is along with various efficiency gains, it's really caused the growth in use of IT to be offset by a decarbonization of IT. So the actual carbon emissions of IT has been relatively stable. It's around 1 or 2%, depending on how you measure it, for the last decade or so. Whereas people at some point thought that it was going to go up a lot, but this offsetting thing has actually kept it at a reasonable level.
And that's in the face, of course, of tremendous IT industry growth.
Yeah, the growth, I mean, the numbers right now go probably up to 2021. So 2022, you get to see a few changes. But the interesting thing right now is that if you look at the industry, there's growth in cloud and the growth in data centers in general. But then we've seen another wave of power going to Bitcoin mining and crypto in general, which has pushed the numbers a little bit more. You can argue about whether that's a good use of electricity or not, but it's been an additional workload that's bumped up the usage, although in some places, they've been trying to use more green energy for that as well. And then just very recently, we've seen all the generative AI take off as a huge category, just really in the last few months. And I think what you'll see going forward, people are concerned about the carbon footprint of these huge AI workloads which are coming in. So there's a few different waves of things going along here.
Yeah, this is really interesting because digitization of human life means more data centers. That means more power. What I find interesting is we are now at a point where we can look at the workloads that are driving the use of the data centers. When it comes to supercomputing, though, you take that entire data center and you apply it to like one app or a very small set of apps. And that also leads to a question of, is that a good use of energy? Is it worth all that energy to advance science? I think that's the question that was asked. And of course, for us, the answer is obviously yes. So what do we think about the supercomputing world?
I think it's very powerful because one of the huge advances we've seen recently is in materials science. And that's very compute intensive. Things like the whole revolution of battery technology. And there's a lot of nanomaterials and very exotic materials. Yeah, that area, it's such a fruitful area right now. You're seeing big advances in the ability to store energy in batteries and get them to be lighter weight. It's just a critical piece of this whole energy transfer. So that's one usage. And then if you look at things like seismic, which has historically been used for oil exploration, that now becomes useful for geothermal exploration. And then the other things are mostly like climate modeling. That's another supercomputer application, one that I worked a little bit with NCAR, and they're getting their global model onto AWS so that anyone can just go there and rerun it and higher resolution and things like that. That was one of the projects we had. But there's a lot of ability to use compute power to solve for the problems that climate has. And if we can move electrons around, which is computing, to make it more efficient to move the atoms around, that's where the energy really is, then you're providing optimization for these physical processes where the real carbon is being emitted around the world.
I think that's absolutely right. Supercomputing is, in fact, the answer to the climate challenge and a big vehicle to solve the problems that are left over from industrialization. And it's part of the solution, not part of the problem. Now, within supercomputing, we also do a very good job of actually starting to track this as of the last many years now, including Green 500. So let's take a look at how that has been driving better efficiency.
And the measurement is gigaflops per watt. That seems like a commonsensical way of looking at it. Do you all agree?
It's certainly an easier way of doing it. So you've got your top 500 number of gigawatts peak Rmax, and then you can also report how many kilowatts your machine or your environment, whatever your supercomputer is consuming. Divide the two, and you get put on a different list. And it's interesting to see where the big machines appear on the list, and then there's some smaller ones which are more efficient just because they're running in a smaller environment, I guess. So you can optimize the sweet spot for energy, or you can optimize it for outright performance, and you'll probably be a little bit more hot on there.
Yeah, it's one application. So I think in that sense, it may not be kind of thorough. On the other hand, that application has been a very good proxy for the workloads that run on supercomputers. And what I've also observed is that the measure of gigaflops per watt has steadily improved. So to the extent that we track it, we can actually point to some really serious progress. Now, we expect the next installment of Green 500 within the next several weeks as ISC approaches, but it's been a really good list that we always cover when the new list comes out.
Yeah, so coming in at number one is a system called Henri. I've been told they do like the French pronunciation, and it is spelled
that right? I actually thought it's like Henry, even though it is spelled like it should be Henri.
In any sense, this is a Lenovo system. It's at the Flatiron Institute in New York City, and that comes in at gigaflops to watts ratio of 65. Now, down the list,
Both point out that it's only 405th in the top 500 rank. So it's a 2 petaflop system of 6,000 cores, but it's set up to be a nice, efficient system.
right. Now, at number 6 is the world's number 1 system, Frontier, the first certified exascale system at 52.2. But we also know that Frontier's annual electrical bill at Oak Ridge National Lab is projected to be in the area of $18 to $19 million. So it's a huge energy consumer.
Yeah. The other thing I note is that when you look at what systems are doing well, usually it's the systems that are using the latest technology, which is obviously makes sense.
Yeah.
So Henry is the only system on that list that is using the NVIDIA H100 GPUs.
There we are.
So really the systems that are doing well are AMD MI250s and NVIDIA H Grace Hopper kind of a systems. And that sort of makes sense.
Yeah, but Frontier is about 21 megawatts when it's running and 8.7 million cores. So that's a pretty big piece of real estate to just turn that on and watch all the lights dim in the state, right? But it's still 21 megawatts. It's not given that sort of the capacity, like the generating capacity that Amazon has globally now is 20 gigawatts, right? So in proportion to the footprint of the hyperscalers, I think the HPC footprint itself in aggregate, these are very big individual machines, but it's not like there are thousands of frontier-sized systems. There's just one. So the total aggregate capacity of HPC is relatively small compared to the total aggregate capacity of enterprise computing or cloud or something like that. But these are nice sort of headline-grabbing, very intense, hot machines.
Has anybody calculated the energy uses of cat pictures on internet? There's a metric.
And by the way, maybe another category of measurement on the Green 500 would be actual power source and carbon emissions. So if, for example, any of these systems are powered by a wind turbine farm or solar panels, then that should be taken into consideration.
Yeah, and I think that's kind of if you look around the world, the carbon intensity of the grid, what's called the grid mix, varies not just around the world, but sort of region by region. If you think about the interconnected set of electricity grids, there's a local grid, usually a local electricity supplier, that's interconnected with the next state over, or, there's a few states, like we live in PG&E land here in California, but there's, I guess, Southern Edison if you go a bit further south, and there's other people around, right? And it's, I guess, the Tennessee Authority in Tennessee Valley. Mm-hmm. And so you can go look up, and it's actually provided effectively in real time, the generating capacity in a particular area. They all report to the EPA. And if you go to the Rocky Mountain Institute, they maintain a data set there of all of the emissions of all of basically everywhere in the US and some around the rest of the world as well. So you can see what the current mix is. And you could kind of look at that. Okay, I'm running my test. And at that point, while I was running that test, this is what the mix looks like where we are. But if you're using one of the cloud providers have their own private sources of energy which offset that mix. They're buying their energy from their own wind farms and solar farms that they've paid to get built. So the numbers come up a little different there. But certainly for anything that's running off of the regular grid, you can get some fairly easy estimate that says this is the carbon footprint of it by looking at how much of it is coal, gas, hydro, wind, all these different things, and solar.
So the other thing is when you look at sustainability and energy, there are a few dimensions that emerge. One is that clearly it's an imperative for society to do. That leads into public policy and corporate policy. It leads into the technologies that you must deploy or advance in order to implement those policies. And it also becomes like a marketing imperative because you want to brag about what you're doing. And in some cases, you want to brag about way more than what you're doing. And then you get all these standard bodies and governing bodies, consortia that are forming in the industry. So it's become legitimately a really big deal. Let's look at the dynamics there.
Well, we do know that, for example, some companies are turning to an organization called the Science-Based Targets Initiative, in which case, if you make a full commitment to SBTI, you're actually opening yourself up to being audited by a third party to verify that you're hitting your milestones. And I believe, Adrian, there are other organizations like this.
Yeah, this is one of the things, as you get into this space, there's a a huge number of acronyms of various bodies that do different things and allocate that you can sign up for. So the nice thing about standards is there's so many of them to choose from. It's one of those worlds. And SBTI is quite well known. So the idea here is that you're making a target, which is a target that's supported by the science. So you're going for the science says we should be trying to keep global warming below 1.5 degrees C globally. That's pretty difficult to do, but that if you sign up for that target, then what they're looking at is is the behavior of your company consistent with that target? That's kind of the way they set up a science-based target and following through and doing the right things. Are the policies and the disclosures you're making in alignment with that? So it's a pretty high bar to get to. A lot of people do initial sign up and then you get to say, okay, we're actually delivering on it. And there's a scoring ranking system, the SBTI manager, for how well you're doing against that target.
But as you were saying, there are many more. That's right.
Yeah,
That's
there
right.
are many more. And this comes back to there's a thing called the Task Force, TCFD. It's the Task Force for Climate Disclosure. And they set out a bunch of goals for how you should disclose what's going on. And this is the basis of all these net zero calculations and things like that that people put up. In order for compliance with that, which is really compliance about disclosure, the CDP, the Carbon Disclosure Project, is the thing people sign up for. And the CDP give you a rating based on how well you're disclosing what you're doing. So SBTI is more about what your goals are. Are you setting a good enough goals? And then CDP is more about, are you conforming with the disclosure side of it? And then there are many more similar kinds of things out there. And there's a list of 20 or 30 of these acronyms that I have stashed away somewhere because I can't get them all straight.
And how do you measure what you disclose? Is there a standard or there's some kind of an accuracy to those?
Yeah, there's a standard way of assigning carbon. And this is where there's actually another topic here we should sort of migrate to a bit, which is they're called the three scopes of carbon. And they are defined, everyone uses the same definition for this. But the first one is the fuel you burn. Basically, if you think about the fuel you burn in your car, that's scope one.
Mm-hmm.
Any fuel, gas you burn to heat your house, in a
It's the
personal
source
way
of
of looking
power.
at it. Yeah, but you're actually, the fuel is being turned into carbon by your action, right? You own that fuel, right? The second one is energy you purchase, or somebody else is burning fuel to make energy. It's mostly electricity. There's a few cases where people consume heat directly, but it's almost all the electricity, and that's called scope two. And when we talk about green energy and this green 500, most people think about that. It's the energy consumption piece. If you look at a data center, the fuel burnt is usually the backup generators, and it's a very small proportion. It's usually a fraction of a percent of the total. It's not usually that material. But you can also buy carbon-free diesel fuel or put bigger batteries in and things to reduce that. But then the interesting thing is what's called scope 3, which is where it gets pretty complicated and confusing. But think of this as your supply chain, upstream and downstream. And typically it's all the suppliers where you get everything from. And it includes the concrete you needed to build your data center, the steel to build the racks, the aluminum for your packaging and your machines, the silicon that goes into your machines, and then the shipping of those machines from where they're made to you, the whole supply chain.
Mm-hmm.
As we decarbonize the electricity grid, which is happening pretty quickly over the next few years, the scope 3 supply chain is turning into the biggest proportion. And one example of this, if you think about a solid state disk, a solid state disk has a lot of silicon in it, but it doesn't run very hot. And it turns out that it takes more energy, more carbon to make an SSD than it will emit from the energy use, even with a normal kind of grid mix in its lifetime. So several years of energy use, but the amount of electricity you need to make it is, the carbon for that electricity, for the processes required, is much higher. And if you look at the CPUs and GPUs, they get so hot, they pretty much glow in the dark. So once you get things like that, then the energy use is more than the cost of making the silicon. But the silicon in the SSDs and the GPUs and the CPUs is really what dominates the carbon footprint of an HPC environment. Assuming that you've bought green energy for it, that becomes the next thing that people have to optimize for.
What about other technologies that are under development that'll impact server efficiency?
Yeah, I think there's a few things. Certainly, there's some of the CPU architectures now. A lot of the GPUs really tend to dominate in HPC, but on the CPU level, we're seeing some of the ARM chips be lower, better performance per watt than the Intel architecture chips. And you're seeing that from like Apple doing this with its Macintoshes and things like that. But also in the cloud with the various cloud providers have now got systems which give you better performance per watt and some cost advantages for ARM-based silicon. But I think in HPC, it's really come down to, which GPU you're using. And those are most of the power going into a GPU is in the floating point units and the data movement and the memory bandwidth, which doesn't really depend very much on the CPU instruction set architecture. So it's maybe a bit more of a wash there. But then we were just thinking about the other parts of the system. There's maybe the cooling systems, some of the water cooling systems potentially could give you better power usage efficiency. So think of this as the electricity that's delivered to a data center. How much of it is actually used to do the compute, and how much of that is used as sort of losses in the power conversion systems and to run the cooling system. And typical values for PUE go from about 1.1 for the most efficient data centers to about 2.0 for some of the data centers that may be less efficient, or they're in very hot, humid environments like Singapore, where it's very difficult to cool everything. So water cooling is one area that's potentially interesting. I think, Shaheen, you were talking about photonics.
Well, in general, while when it comes to CPUs, as you both know, I think the fab technology plays a much bigger role than the instruction set architecture. And I think microarchitectures and macroarchitectures have kind of decoupled those. And so I think, Apple M1 is good because it's like 5 nanometers more than compared to 10 nanometers, of course, going to be better, that sort of a thing. So I kind of look at it as advanced technology. So using flash instead of spinning disk is an example of it. Using optical instead of electrical is an example of it, depending on what the use is, of course. But then also there are companies that are saying, I will make sure that your data is compressed and not held in memory when you don't need it. I can power manage different parts of the chip so that you're not using power when you don't need it. So there's more efficient use of the resources that you have that are also technologically based. They could be software, they could be whatnot. So those I see as examples of advanced technology that can reduce your energy usage and make it more efficient. And as you were saying, Adrian, every little bit counts. And as you remove the big guys, the smaller ones become the next big guy. So how did you put it?
It's an all of the above thing.
Yeah, that's what. It's all of the above
So
strategy.
if anyone says, well, that way of solving for climate change won't solve the problem, here's another way. So it's fine to be just working on one of them, right? Because there's a broad front here and all of the different solutions are needed. A lot of need to invest in every possible level of technology and apply everything. And they sort of compound together a little bit as well. So if you can use less energy and then you can use greener energy, then those two savings compound together to give you a better outcome.
Right on.
Allow me to introduce you to Henry, the world's most energy-efficient supercomputer at the Flatiron Institute in New York City. What sets Henry apart? It clocks in at just over 65 billion flops per watt of power, making it top the Green 500 list of energy-efficient supercomputers. Beyond speeds and feeds, Henry opens possibilities for doing new kinds of science and driving new discoveries. And it's powered by Lenovo ThinkSystems and NVIDIA GPUs. Learn more at news.lenovo.com and search for Green 500. That's one word, GREEN 500.
So there's also a big policy part of this that we mentioned early on that we should get back to, because this must be really difficult for lawmakers, like all the other technology stuff can be.
Yeah, and it's being particularly driven out of Europe right now. So the European Commission has put together some rules on climate disclosure, but there's two sides to it. One is climate risk, which is actually an area for maybe some other HPC applications. You've got to be able to model what the risk to your company is of what's going on, the impact of rising sea levels and extreme weather and things like that, and market changes. So there's climate risk, but there's also carbon disclosure, which is being mandated. And the rules came into effect at the end of 2021, I believe. And you had 2022 to get your act together. You're supposed to measure 2023 and you're supposed to report it in 2024. And that's the European rules sort of timeline. that people are working to. But it's a bit like GDPR. It spreads out from Europe. Just because Europe's doing it, now all those companies in Europe will be coming to you and saying, okay, in order for me to comply with my local rules, you're part of my supply chain. I need to know what your carbon footprint is so that I can add it into mine. So they need to know the scope 3 supply chain. So it's spreading out. And there are some similar rules in the US being discussed, but they're a little bit further behind, and they have to get through a few more political jumping through hoops before they become, but they're currently in a discussion phase there. But it's likely that the large US companies are already having to conform with the European rules anyway, regardless of what the US thinks, just because it's like GDPR, it's just going to spread around the world.
I think so.
Well, and it's interesting. We're seeing legislative efforts at state and local levels that the hyperscalers and data center companies are going to have to deal with. For example, there was a proposed legislation in Oregon earlier this year that did fail. It didn't get out of committee, but it set pretty aggressive annual targets for reduction in greenhouse emissions. And with your background at Amazon, Adrian, it was kind of interesting because, there were reports in the media that Amazon AWS was lobbying pretty aggressively behind the scenes to kill the bill.
Yeah, I think in general, Amazon doesn't like having its ability to decide what it wants to do legislated. So they just have a standard reaction
Aversion
to say
to that.
aversion. They just,
Reflective,
yeah. So I think that's kind of, I mean, I wasn't involved in this at all, but
Yeah.
that's sort of like what I expect them is to anything that constrains their ability to make the right business decision. But what's happening in Oregon's interesting because it's historically had a lot of hydropower and very green electricity. So a lot of data centers were set up there, although it's not particularly a good place to set up. The internet connectivity to Oregon isn't particularly great, but it was a good place to get cheap electricity and green electricity. But what's happened, I think, is that there are now so many data centers there that they've run out of power from the hydro systems, and they're having to start putting in additional power sources. And this is where the problem's coming along because they have peaker plants, which are gas-powered plants that turn on when there's peak needs for electricity. And, when everyone's running at once in the summer or whatever, these peaker plants are running. So you're not really getting that green electricity anymore. So they have to figure out how to put in more wind and solar. And then the local communities are saying, hang on a minute, we should stop giving big subsidies to these things to turn up to use this, quote, cheap electricity, which is no longer cheap because you've used up all the cheap electricity and we're having to do more bigger investments in our own quality of life and everything. So you start to see those kinds of effects. It's really, I think this is largely because the hyperscalers have hyperscaled. They're no longer just a small thing on the side anymore. It's become, Amazon's now got their annual revenue is bigger than all the other. I think it's the biggest revenue enterprise computing provider now. They're bigger than HP and IBM in annual revenue. This isn't a little thing on the side that it was a decade or so ago, right? It's turned into the mainstream.
Yeah, this really shows how difficult this is for politicians because I bet you, like you alluded to, Adrian, they'd had incentives to attract a famous company who's going to build a famous data center in the state and not probably thinking far enough out that maybe this is too good an offer and we're going to be overwhelmed by it. And now we have to invest in power sources when we didn't plan on doing so.
Yeah, and this has happened there's similar reactions in Dublin as well. In Ireland, there's some similar pushback. And then there's something, I think, in London, in like the West London area, they can't put any more data centers in because there isn't enough power for the houses. And, it's like a regional problem. They don't. And this another big problem we have is the interconnect. You've got to be able to run those long distance power lines that can interconnect these sort of islands of generation.
Right.
And the whole system itself is pretty complicated, just keeping it working.
Well, I have to say, part of the reason I'm down this path is because I think a lot of the political processes and attraction of businesses into geographies is driven by industrial mindset, where they think it's a factory and it's going to generate a lot of jobs and it's going to do this and we better provide the incentives. Whereas in the information economy, it's a different dynamics. You're going to need the power, you're going to need this. It's not just kind of roads and bridges. And I'm not sure all of these are being taken into account.
Yeah, there's usually some local tax revenue or something like that they get out of it. But yeah, it's like these big industrial plants, like people put up chemical plants and they don't generate very many local jobs. They sort of pollute the environment. So I think this is a general problem of industrialization, right? Where are you going to put these things and whose backyard are you going to end up in? And how much lobbying power do they have?
It's an interesting point. Our friend Bob Sorensen at Hyperion Research,
Mhm.
I saw him give a presentation about these huge data centers that are around Northern Virginia. And I think they have very favorable pricing and taxes that have attracted, data centers, hundreds of thousands of square feet. And as he said, the employee parking lot has like a half a dozen cars in it.
Mhm.
It's kind of a strange contrast.
Yeah.
Yeah, you don't need people in there. Yeah.
Ashburn should have "Welcome to the Cloud" on it, on the
Yeah,
city
exactly.
sign as you drive into it. It's because that's pretty much where the cloud lives.
Now, I want to talk about offset, carbon offset. And the way I see it is that you either make up for it or you pay for it so somebody else can make up for it. Can we talk a little bit about what the state of the market is for that?
Yeah, this is a sort of a minefield. There are good offsets and bad offsets, and part of the problem is trying to figure out which one's which and who's doing what. And that's why things like SBTI and the Carbon Disclosure Project, they will look at where you got your offsets and are they good ones. So, for example, really think of offsets working in two different ways. You can either do it at the energy level or at the carbon level. Right. If you
Hmm.
go and buy a lot of renewable energy by contracting with an energy supplier who is connected to the same grid as you to say, that wind farm over there, I'm buying your output. And yeah, it's kind of the electron's an electron, and you're stuffing electrons in the grid over there, and I'm pulling them out over here. And that's a good way of doing energy level offsetting. So you do it with power purchase agreements and things called RECs, renewable energy credits, where you say you're selling the fact that it's green as a little premium. That's the best way of doing it. The trouble is that they let you trade these things across borders. So you can have a renewable energy in one country and you can actually sell it to another country, even though you're not really connected to them. And here you're really saying, well, I'm generating less carbon here and you're generating more there, and we're offsetting through the carbon cycle. So you have to look at an offset and say, if it's energy and it's connected, it's good. If it's disconnected, it's not really an energy offset anymore. So then you have to look at carbon offsets and decide, is this a good carbon offset or not? And you can buy carbon offsets quite cheaply. And what you're buying is somebody saying, yeah, I planted some trees. And you go back a year or so later and the trees have all died. And it's just not, it's a super cheap environment, right? So if you
I
do
didn't
it
know I
right,
needed to water them.
yeah, or the fire came through 'em. And actually, this did happen. Some of the Microsoft investment in forestry, one of the forest fires went through and burnt them all. So you have to buy insurance to go replant them again, and so there's an insurance process that covers it. So it is okay in the long run, but yeah, it is harder to do. So one of the better ones will be, they will be properly maintained. They will still be there in another decade or two, and there'll be insurance in case that they burn down or something. But that ends up being a more expensive and a more higher quality carbon offset. And then finally, there's carbon removal, where people are paying to just do direct carbon removal, use some cheap energy to try and suck carbon out of the air or out of the sea or something like that, and to actually sequester it, put the carbon back in the ground. That's very expensive, but it's sort of in the early stages of development right now.
Excellent.
Adrian,
Excellent.
can I ask you, as a role, looking at big picture, when we hear about the big hyperscalers, big tech companies, and I guess this would also apply to major data centers and HPC centers, when they make statements that they're committed to being 100% renewable. For example, speaking of Amazon, they say they're going to be 100% renewable by 2025, which is 5 years ahead of their original commitment. Should we believe, I'm not pointing out Amazon, do we believe or not believe them, but as a rule, should we believe the projections of the big tech companies?
Yeah, I think certainly if you put out something that you know is not true, then you'll get into trouble for it, right? So these are all in good faith, the best estimates they have, right? So the question then is, how are they doing it and are they going to get there? So with Amazon, the goal is 2030 that they've committed to, and they're on a path to 2025. And if you look at the percentage that basically they're saying we're going to be 100% renewable energy net zero, right? So this is a net zero. That means that it doesn't mean that it's zero carbon emissions. It means they're basically buying as much green energy as they're consuming. So at various times of the day or night, you might have a bit of extra energy, and then some of it's carbon overnight, and you've got extra green energy that you weren't using during the day that somebody else uses. So it's kind of, that's where it gets a bit sloppy around this net zero place, but it's a reasonable goal because most people are so far from it. But Amazon publishes the number every year for where it is on that path, and I think it went from 75 to 85% from 2020 to 2021. and it's working towards that 100%. But this is a global number for Amazon. It's not the AWS number. It includes the delivery fleet, the warehouses, the airline, the manufacturing
Oh, wow.
facilities they have. It's all of Amazon. So when you look at the Amazon numbers, they don't break out AWS separately. What AWS says, they have a list of data center regions in the world where they are at least 95% renewable. And it's basically all of the US and European regions are currently on that list. The regions that aren't on that list are primarily in Asia, and this is where the problem is. Because you can build wind farms and solar farms in Europe and the US relatively easily. There's lots of them. And there's a map on the AWS sustainability site showing where they have all these data centers around the world. And they have a few of them in Europe. They have a few in India and Australia, Japan, I think Indonesia. They're working, I forget exactly where they are, but they're working on all the places where they have regions they want to have solar and wind and batteries. But it's still, the grid mix in Asia is still very coal-based and very dirty, very, very carbon intensive. And this is why the silicon, which is made mostly in Japan, Korea, Taiwan, and China, right? That's why the silicon has so much carbon in it. And those companies have made commitments to companies like TSMC in Taiwan have made commitments to by 2050 that they will be net zero and they'll decarbonize and whatever. So it's sort of the supply chain, particularly the Asian supply chain, is running a decade or two behind the US. And I'd say Europe is ahead. The US is a few years behind, but not far behind. And then Asia is running a decade or so behind or something like that in terms of decarbonizing. And that's kind of the challenge for all of the companies is to decarbonize Asia.
Okay.
Very good. Excellent. So maybe this is a good place to conclude this episode. There's still a few things we didn't talk about that we're going to have to come and talk about in a future episode, specifically all the different cooling technologies that are out there. But I had a lot of fun. Thank you.
Yeah, thanks. Always good to chat. And yeah, this is such a complicated area. There's a lot of things that aren't obvious and a lot of acronyms, and it's taken me a couple of years just to kind of become at least passingly familiar with all the different things going on here. So don't envy anyone that's trying to figure out how to take their entire HPC system and work out how to make sure everyone's going to agree that it's green. It's a lot of work.
All right. Well, Adrian, you've been a wealth of knowledge, and thanks so much for your time.
Yeah, thank you.
All right. Thank you. Take care.
That's it for this episode of the @HPC podcast.
Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen.
The @HPC podcast is a production of OrionX in association with Inside HPC.
Thank you for listening.